All right, guys, quick little video here about a different type of extrema. The other day we talked about relative extrema, and this is going to talk about global extrema. It's similar, but just kind of, I have a picture drawn here for you guys. And hopefully you realize now that this is your relative max. This is a second relative max. This is a relative minimum, as is this point over here. Now, global extrema is extrema on a closed domain, essentially. It is the absolute highest value or the absolute lowest value that a graph goes. When you have arrows like this graph at this point in time does, these arrows are indicating that this graph is going down to infinity or going up to positive infinity. So there's no like by far absolute endpoint because this graph technically keeps on going. If I were to, instead of having an arrow, if I were to have it chopped off and I have a closed interval, I've now created a closed spot on that side, and I can do the same over here. Now, since I have a closed interval, now I'm guaranteed to have an absolute or a global maximum over the interval and a global minimum over the area. Over the interval. So what that means is simply the highest point that the graph goes. And depending upon where your endpoints are, it could either be at your endpoint, like this max is. See how this max technically is higher than either one of these relative maxes. So this, in this case, would be a global max. And my picture is kind of deceiving. Let's just pretend this one is lower than that one. My global minimum could either have happened at my endpoint, that depending upon where I chopped this off. If I chopped it off down here, then my global minimum would be all the way down there. But since I chopped this one up here, then it leads to the fact that my global min would be at a place where I have a relative min, and that relative min will now change to a global min instead of a relative. So global maxes and mins can happen either at an endpoint or at a place where we have relative extrema. So the type of example that we are going to see is just find me global extrema. So I have an example up here on the board. And basically what that means is we could either have a global max or min at -2, one endpoint, at 5, another endpoint, or if we have any places where we have any stationary points or critical numbers in the problem. So let's find our derivative to see if we have any places where we have any critical numbers or stationary points. I'm going to set that derivative equal to 0. It's 4. I am going to have 2 of them. I'm going to have one at 0 and I'm going to have one at 4. And it just so happens that both 0 and 4 fall in the domain that we're working on. So basically, in terms of global, we just want to see like the y values of each thing. Do we want to see, is this y value higher than this y value or higher than my endpoint? So we're really going to just find the y values for each of these 4 places, for 0, for 4, and our 2 endpoints. I, out of habit, tend to make a chart just to kind of keep things easier, but that might be your personal preference. But I make a chart. I say, well, if I was going from left to right on my graph, I have my left endpoint, which is going to be at x equals -2. I come across my first critical point at x equals 0, or stationary point in IB world. I come across my second one at x equals 4, and I come across my right endpoint then at x equals 5. And I basically just want to see what my y value is at each of the points, and I'll know which one's the highest and I'll know which one's the lowest. So basically you're going to just take these numbers and plug them into the original problem. So if I were to plug in -2, I'm going to have -8. -6 times +4 is going to be a -24 plus 5, which is going to end up being -27. I plug in 0, 0 minus 0 plus 5 is 5. That one's easy. 4 cubed is 64 minus 6 times 16 plus 5. We're going to get -27. And 5 cubed minus 6 times 5 squared, which is 25, plus 5 is going to be -20. So this x equals, or at x equals 0, our y value of 5 is the highest it's going to be. So that's going to be your global max. And our global min happens at 2 places. Happens at -2, -27, and it happens at 4, -27. It's going to be your global minimum value. So you're just checking y values to see, are your endpoints higher, or where we have critical numbers, or essentially where we could have any any relative extrema, we are going to have our global max at those places.